Hello, this is Shannon Seaver, and we are looking at section 5.6b, scientific notation today. On our agenda is to convert scientific notation to decimal notation, and then back again from decimal notation to scientific notation. We're going to perform computations using scientific notation, and we are going to solve applied problems using scientific notation. So first of all, we need to remember what scientific notation is. It is a positive number written in this form. Notice it's a times 10 to the nth power, where a is a number greater or equal to 1 and less than 10. That's something to remember because this would not be considered scientific notation standard format. So if I had 23.4 times 10 to the third, that would not be in correct format because this number here needs to be between 1 and 10. However, if I wrote it 2.34 times 10 to the fourth, that would be incorrect format. So it needs to be positive and between 1 and 10. So first of all, we have two numbers here that we need to convert from scientific notation to decimal notation. What I'm going to do is I'm going to write this out right here first of all as 2.6 and leave myself some room to go in either direction. I notice here that I have 10 to the 7th. So really I'm just moving the decimal place 7 times. So it'll be 1, 2, 3, 4, 5, 6, 7. And I'm filling in my little swoops there with zeros, the technical term of swoop. Okay, so now, if I rewrite this out, I can put commas in like that. So I have 26 million. Now I'm going to do the same thing with this one. I'll put 1.1 here. Notice that this one's to the negative power. On the one above it, we went to the right. On this one, we are going to go to the left. I'm going to move over 4 spots. 1, 2, 3, 4. And I'm going to put my decimal right here. So I'll have 0, 0, 0. Another way you can think about it when you have a negative exponent on this is you know that you're going to need a total of 4 zeros but a decimal after the first one. So notice I have 1, 2, 3, 4 zeros, and this is to the negative 4. So as long as I have a decimal between my first 2 zeros, then that would be correct. So if I write this out now, 0.00011. Now I want you to stop the video and try these two on your own and then come back and check. Hopefully these are the two numbers you got. Now we're going the other direction. We are going to convert from decimal to scientific notation. Keeping in mind that we have to keep our numbers between 1 and 10, I'm going to take the first 2 digits here and I'm going to call it 4.6. And since my decimal is going here between the 4 and the 6, I need to make sure that I have, and we can count these out, 1, 2, 3, 4, 5, 6 as my exponent for my 10 there. We're going to do the same thing with this one. We're going to take 2 and 3, and we're going to turn that into 2.3. And being that this is a decimal, it's a fraction, we're going to count the number of zeros we have. We have 1, 2, 3, 4, 5. Because it's a decimal, we're going to go negative, and it's going to be 5. So stop the video and try these two on your own. Check your work here and see if you got the right answers. If not, bring questions to class and I'll help you through it there. Okay, so let's look at an application problem using scientific notation now. In 2005, the federal cost of Social Security was $519 billion. It says express this in scientific notation. So I'm going to write this as 5.19 because we can't say 519 in our scientific notation. It needs to be between 1 and 10. So this would be times 10. And remember, to make a million, you need 6 zeros. So to make a billion, you're going to need 9 spots. So this would be 5.19 times 10 to the 9th. All right. Multiplying numbers in scientific notation. So here we have an example where we need to multiply two numbers that are in scientific notation. And I'm going to break this down into two parts. So I'm going to put the 3.4 times 2 in the first part. And this would be the times. And then I'm going to have the tens. 10.9, 10 to the 9th times 10 to the 5th. So this is where we're going to use our exponent properties that we learned yesterday. So 3.4 times 2 is the same as 6.8. And this will be times 10. And because this is in, these are exponents, we're going to add the exponents because they have the same base. So this would be 9 plus a negative 5. It would be 4. So our answer on this one is 6.8 times 10 to the 4th. Now I want you to stop the video and try this one on your own and come back and check your work. So I got the answer of 5.2 times 10 to the 5th. We are going to do the same kind of thing here for divide. So I can write this one as 8.4 divided by 4 times 10 to the negative 7 divided by 10 to the negative 4. Okay, so if I take 4 into 8.4, that's the same as saying 2.1. And then if you remember, if I'm looking at this part right here, our property rules for exponents that are being divided is you're going to actually subtract the exponent. So this would be like saying 10 to the negative 7 minus a 4. And in this case, it's a negative 4 that we're subtracting from it. So I need to write that here. So minus a negative 4. So what happens when you have two negatives? They become positive. So now we have negative 7 plus 4. So this would become 10 to the negative 3rd. So our answer in this case is 2.1 times 10 to the negative 3rd. Now here's your chance to try it as well. Pause the video and come back and check your work. Okay, so the answer I got for this one was 2.3 times 10 to the negative 6. Okay, so on this one, we need to express the product in scientific notation and in decimal notation. So the easiest way to actually solve this problem is to first put it in scientific notation. So I'm going to take this one and put it in scientific notation. And I have 1, 2, 3, 4 zeros in front of it. So I can say it is 6.4 times 10 to the negative 4th. And I want to multiply that by 9.4 times 10, and let's count how many we have here. We have 3, 6, 9, so to the 9th power. And now I can just take 6.4 and 9.4, put them together, times 10 to the negative 4th times 10 to the 9th. So let's take these first two and multiply them. If you don't have a calculator, you can stack them and multiply them. So I could do 6.4 times 9.4, and let's multiply this. We have 4 times 4 is 16. I'm going to carry the 1. 4 times 6 is 24. That makes it 25. Now I'm going to put a 0 in here. 9 times 4 is 36. Carry the 3. 9 times 6 is 54 plus 3, 57. If we add them all together, we have 6, 11, this becomes a 10, and a 6. Because we have 2 decimal places, I'm going to have 2 decimal places here. So 1, 2, my decimal is here. So on this one, we have 60.16 times 10. And if we use our exponent rule here, it would be -4 plus 9. That becomes a positive 5. Now, this number is not between 1 and 10, and it needs to be. I need to move this decimal over 1 to the left to make this 6.016. But if I do that, I need to add 1 to this. So if I move this direction, I'm adding to the exponent. If I have to move my decimal this direction, I'm subtracting from the exponent. So it depends on what your final answer is after you do your operations as to which way you're going to move. Since I moved my decimal this way, it is to the 6th now, and that is my answer in scientific notation. But I need to do part B. I need to make it back into decimal notation. So I'm going to take 6.016 and I'm going to move my decimal to the right 6 places. So 1, 2, 3, 4, 5, 6. So I need to add 3 more zeros to it. And now my final answer for part B is 6016000, and that would be 6,016,000. So this is part B. An application. This one's really an interesting one, and it's something that's kind of important, I think, to all of you. And as of December 2006, the national debt was 8.6 trillion, or 8.6 times 10 to the 12th dollars. That's a lot of money. At that time, the U.S. population was approximately 300 million people, or 3 times 10 to the 8th. If the national debt was evenly divided among every individual in the United States, how much would each citizen have to pay? So we're going to take the first one and divide it by the number of people. So 8.6 times 10 to the 12th, and that needs to be divided by 3 times 10 to the 8th. Okay, so I'm going to look at just these two numbers right now first, and then we'll worry about the tens in a minute. 3 goes into 8.6. Well, that's twice. 2 times 3 is 6. And I have 2, and I'm going to bring down the 6 now. And I'm going to put my decimal here because that's where it is on this one. So 3 goes into 26. That's 8 times. 8 times 3, 24. And now I have 2 again, and I will bring down a 0. 3 goes into 20. 6 times. 6 times 3 is 18. And then I have a 2. And notice I'm going to have a repeating 6 here. Okay? So my answer on this one, first of all, is going to be 2.86, and I'm just going to leave it 7, because if you think about 2.86666 repeating, if I round it up, it's going to go to a 7. And that would be times. Now we're going to look at these ones. Remember, if we have an exponent to the 12th and then divided by an exponent to the 8th, we're actually subtracting the exponents. So that will be 12 minus 8, which will be 4. So our answer to this is this in scientific notation. And I would say most people don't really know what that really means in dollar amount. So let's change this to decimal notation. So we're going to move this decimal over 4 spots. So 1, 2, 3, 4. So our answer is $28,670 a piece is what we would have to pay in order to make up our national debt. That's the end of this lesson. If you have any questions, please bring them to class.